Is this clear? Clear. All right, great. Now, if this is clear, then tell me how many time series do we have on this picture, on this table? It's not a trick question. How many time series do we have on this table? I'm listening. How many? How many? Yes? One time series. Okay. That's one. What? You think 6?
6.
So we have 1, we have 6. 3 time series. So we have 1, 6, 3. Anybody thinks anything else? Any other views? All right, so we have 1, 3, and 6. 2. Oh, yeah. So we have 1, 2, 3, and 6. So let's count. 1, 2, 3, 4, 5, 6. And 6 is the correct answer. Why? Well, let's have a look. Let's have a look at this row. What are the dimensions? Okay, we don't have a DSD, but we can sort of guess the dimensions. The indicator is population below $1 a day. The reference area is Rwanda. And then we have figures for 2000, 2006, 2011. These 3 figures, they have the same indicator and the same reference area. The only thing that's different is time. And that means that they belong to the same time series, one time series. Now, why is this a different time series? It's because it has the same indicator but a different reference area. And reference area is practically always a dimension. They are different in that dimension, reference area, and that means that they belong to a different time series. And if you look at this row, again, we have 2 figures. One is population below $1 a day percentage. Reference area state of Palestine. The second figure, indicated population below $1 a day percentage. Reference area state of Palestine. Again, the same dimensions. The only dimension that's different is time. And that means that these 2 belong to the same time series. Is this clear? I hope it's clear, because it wasn't clear to me when I was starting to study SDMX back in 2007 or 2008. I couldn't get around this concept, because it wasn't explained properly. Once I understood what a time series was, which of course is very easy, but once I did that, then the rest was plain safe. Is this clear? Okay, great. Time series is not the only possible representation of data in SDMX. Basically, a time series means that you choose time to transpose your data. But in principle, it doesn't have to be time. It can be another dimension or even a set of dimensions. So in SDMX 2.0, such representation was called cross-sectional, which means that you use another observation, another dimension, not time, but another dimension to transpose your data. In SDMX 2.1, they went one step further. So now, in principle, you just specify which dimension or dimensions is specified at the observation. But in reality, almost always we use time series representation because this is the most natural representation for aggregated data. However, if you want to disseminate data for some reason, for a single survey or census, so we are not constructing time series because it all refers to the same time period if we make such a decision. Then you can choose another concept or a group of concepts to report the data. So let's have a look at this table. Net enrollment ratio in primary education. For 3 countries, Morocco, State of Palestine, and how many time series do we have here? How many time series do we have in this table? Not a trick question, pretty straightforward. 9, that's right. We have 9 time series here. And which dimensions do we have in this table? Well, actually, this is not quite correct because you can structure a dimension differently. But in this case, aside from reference area and indicator, we also have sex. Now, you can make sex part of the indicator. So you can create indicators, total net enrollment ratio in primary education, both sexes. And then another indicator, total net enrollment ratio in primary education, boys and girls. But that's usually not a good style. Usually it's easier to create a separate dimension for sex. But whichever way you use it, it's still time series. It's still 9 time series. Because whether you have an explicit dimension sex or not, you will still have 9 time series of observations that are different only in their time. So let's have a look at a slice of that. Table, and instead of time, we can transform it into a cross-sectional representation, where the dimension that is used to transpose the data is sex, not time. But even here, time is still. So it's just another way to represent the same data, another view of the same data. Questions? That's all. Keys. You know what a key is, right? When you have a ticket to the theater, what's the key? key is, a key is something that identifies an observation or a group of observations. If you pick a ticket to a performance in a theater, it will say something like section 1, row 12, seat 25. And this is your key, section 1, row 12, seat 25. This is your key. It's what enables you to unambiguously locate your seat. In the same way, it works in SDMX. Series key uniquely identify as a series, and because almost always a series is a time series, the key consists of all dimensions except time. Okay? So what it means is a series key. It does not identify a single observation, but it will identify all observations that belong to a time series, that is, all observations which are rather different in their time dimension. So to go back to our example of a theater ticket, how might a row key look like? So we have a seat key which looks like section 1, row 12, seat 25. How would a row key look like? How would a key look like that identifies all seats in a row? No ideas? No ideas? There's no penalty for guessing. Go ahead. So you have a ticket that says section 1, row 12, seat 25. This is your seat key. This is what helps you find your seat. How do you find all seats in a row? What's a row key look like? You got? Code? We're not dealing with codes really here. We're dealing with section row and seat numbers. What would be a row key? Who can guess? Timur, I think you can, looks like you can guess. Yes. It would be something like section 1, row 12. In this case, if you say section 1, row 12, that identifies all seats in that row. You cannot use that key to find your seat, because you don't know your seat number. But you can use that key to find all the seats in that row. Right? So you remove the seat number from your key, and that gives you an identifier for all seats in the row. Same thing here. You look at all the dimensions, you take the time out, and that will identify all the dimensions, all the observations that belong to your time series. A series key consists of all dimensions except time. Group key, all right, it can uniquely identify a group of series, in this case time series. It consists of a subset of keys, so that kind of, you're taking it one step higher. For example, if you say section 1, that identifies all seats in the section, all seats and all rows in the section. It hasn't been used, I mean, it's an elegant idea. It hasn't been used very widely in SDMX 2.1. It's probably going to use the idea of groups and attachment to groups. It's probably going to be used a lot more intensively in SDMX 3.0 because it's essential to reference metadata in SDMX Questions? All right. Now, we often talk about data and metadata. What is the definition of metadata? How do you translate metadata into what is the explanation? Well, if you look it up at Wikipedia, but please don't cheat. What will it say? What is metadata? Data about data, that's right. That's what meta stands for. So, what do we mean data about data? Well, if your data has a code BKK, then you need something else to tell you that BKK is the Bangkok International Airport. And that is data about data. And that is, in this case, what we call structural metadata. A code list that says that BKK is Bangkok International Airport, JFK is John F. Kennedy International Airport of New York City, and FRU is the International Airport of Bishkek. This is structural metadata. Concept scheme is your structural metadata. DSD is the structural metadata. Identifiers and descriptors. This is what you need to understand what your data represents. And this is what we have covered so far. But this is not the only kind of metadata. Reference metadata is what describes the content and quality of the data. So we have definitions, comments, and limitations, quality, and so on. I have a question. Why do we need reference metadata? Why do we need reference metadata? Any ideas? Well, let me give you an example from real life. A few years ago, I went to a country and I helped them map their SDG indicators to the global DSD, and then we compared the national and global data sets. And then we looked at indicator 611, or is it 661? Proportion of population with access to an improved water source. The national figure was, I think, 71%. The global figure was, the WHO figure was 6.8%. So you have the same indicator where the national and global figures are different by an order of magnitude. The country was appalled. They asked, what is WHO thinking? The access to water is a major priority for our government. The government has invested a lot, hundreds of millions of dollars, into improving the population's access to safe water. And now they tell us that we only have 7% of population that can access that. And then we went to and looked at the definitions of the indicator, of the global indicator and of the national indicator. And then it turns out that the global indicator, population with access to an improved water source, measures the proportion of population that have access to an improved water source on premises, in the building. Whereas the national indicator measured the proportion of population with access to an improved water source within walking distance. Not necessarily in the building, but maybe it's in the center of a village. And that is what explains the huge difference between the global and national indicator. And that is why we need reference metadata. Because if you look at just the indicator titles, they're the same. But if you look at the figures, they're completely different. That cannot be. That cannot happen. And if it was allowed to persist that situation, it undermines people's trust in your data. Because when people look at it and they see such a huge difference between the global and national figure, they don't know which figure to trust. So in that case, the reference metadata helped us find that issue and helped us realize that this was the case of our own mapping. Yes, it was an indicator, but it was not the same indicator as the global one, and should not have been mapped to the global one. This is why you need reference metadata. This is why you need information about the definition of an indicator, methodology for its calculation, sources for the indicator, and all the other aspects that let you correctly interpret the figures. So an SDMX reference metadata can be stored or exchanged separately or now together with the data, can be indexed, searched, reported for defined structure. And now I'm going to talk about, very briefly, about metadata structure definition. So an SDMX MSD defines the type of object to which reference metadata can be attached. And it can be DSD data flow, data set, data. It helps you describe the components of the key that identify the target objects and concepts that are used to express metadata, such as indicator definition, quality management. I will go very briefly over metadata. Why? It's because in SDMX 3.0, our reference metadata was completely overhauled. Because the thing is that the reference metadata in SDMX 2.1 was difficult to use for various reasons. And which is why there was hardly any support in tools. So in reference metadata, in the case of SDMX 3.0, the support for reference metadata was simplified and improved. Now, you still have metadata structure definitions. However, you can also define your reference metadata as part of the data structure. And then you can transmit data and reference metadata in the same data set, in the same message. And but you still have MSD, so you still can transmit reference metadata as it was in SDMX2. Now you might ask, why do you need both approaches? And the answer is, you can define reference metadata in the DSD for that type of metadata which is close to data. And then you can also have reference metadata which are far from the data. Those you can describe using the metadata structure definition. For example, if we're talking about things like indicated definition or method of computation, this is something that you might describe as part of your DSD. Again, you can still do it as part of the MSD, which is how we do it in SDMX. But this is relatively close to the data. And someone who is looking at your SDG data set, it would be useful if they clicked on the observation and immediately got the definition for the indicator for the observation. Right? So this is something which you might want to describe, to declare as part of your DSD. But then if you have something like statistical law, it's also reference metadata. But that's probably not necessarily what you will need to look up when you look at a particular data set, right? So for things like that, statistical law, or let's say territorial division, or organization of the national statistical system, this is something that probably you will not want to declare as part of your DSD. It's easier to have it as part of your metadata structure definition separately. So, what we hope and expect is that thanks to the improved and simplified support of reference metadata in SDMX 3.0, we'll have more support for that in the tools. And then that will lead to a much broader usage of reference metadata. And reference metadata is actually, it's not only important, but the implementation of SDMX for reference metadata brings a lot of benefits. There are very few functioning examples of reference metadata exchange, one of which is the SDGs, which we built at UNSD. And the thing is, once we did that, we converted our reference metadata into SDMX, published it in an API. So now if you go to the SDG Global Database, when you click on an observation, you can see the indicated definition and method of computation and all the other reference metadata that comes associated. And this is huge, and this is great, and this is very difficult to achieve, because you need to convert, in order to make that work, really, and to make it sustainable, you need to convert the metadata into a machine-readable format, and then expose it in an API. And we did that at UNSD. And our experience, in large part, led to the improvements with reference metadata. Okay, I think I'll need to go back to the microphone. Okay, data flow and metadata flow. Data flow is something so easy, so simple, that sometimes it's very difficult to explain. What is a data flow?
there are different ways of thinking about the data flow. It can be thought of as a view on the data structure definition. If you have, for example, just to give you a simple example, and this is what Thailand has done. Not the global, not TNSO, but Thailand. If you look at their SDG data set, you will see that they have Thailand's SDG data set defined in accordance with the global data structure definition. And they have a data flow where you can get all the data. But then what Thailand has also done is they established 17 data flows for each of the 17 goals. And so when you look at the data flow for goal 5, you will only see indicators for goal 5. And if you have look at the data flow for goal 12, then you only see indicators for that goal. So it makes it easier for you to consume the data, to find the data, to locate the data. This is in the case of the dissemination. In the case of data exchange, you can think of a data flow as a communications channel. So to use a similar example, if you have a data flow for goal 5, and then someone tries to report an indicator from goal 16 against that data flow, it will be rejected. Right? So, and this is what a data flow is. It's a view on the data set, or it's a communication channel. In the simplest form, a data flow defines any data valid according to a TSD, but then you can also choose to slice that TSD into sections, and then expose it as multiple data flows. And similarly, a metadata flow defines a view of an MSD. Okay, so I said before that you can have a data flow for goal 5, and if someone tries to report an indicator for goal 6, then that indicator will work against that data flow, then it will be rejected. But how does it happen in practice? How do you tell the computer that goal 5 only has these indicators, but not all the others? And you achieve this using SDMX content constraints. So, content constraints can be used to define which codes or combinations of codes are allowed or disallowed. And the thing is, content constraints define a more granular validation rules than simple structural validation. Now, if you look at the SDG indicators, there is an indicator land area covered by forest. Proportion of land area covered by forest. A nice environmental indicator. And so you're mapping your data set and sending it to us. And then we find that your data set for this indicator has 3 time series. Proportion of land area covered by forest, sex male, proportion of land area covered by forest sex female, and proportion of land area covered by forest sex total. Does it make sense? No, it doesn't. It doesn't because land area covered by forest cannot be disaggregated by sex. However, it's a valid indicator, and it's a valid dimension. From the point of view of the TSD, there's nothing wrong with disaggregating an indicator such as proportion of land area covered by forest by sex. So, it's structurally valid, but it doesn't make sense. We need something else, an additional mechanism to tell the computer which combinations of codes are valid and which are invalid. And this is what we use the content constraints for. There are two major types of content constraints. They're actually, this is by nature. There's also a classification of content constraints by purpose, but I won't go into it now. Cube region constraints define valid or invalid codes as a subset of those defined in the TSD code list. For example, when Thailand was splitting its SDG dataset by the goal, I don't know how they did it, but it would make sense to define a cube region constraint, which for goal 5 would include only series codes for goal 5. In the case of the global SDG data flow, we have the country global SDG data flow, which is used for reporting by countries. And it has a cube region content constraints attached that says that for this data flow, the only valid value for reporting type is national, is prod M. So that ensures that global data cannot be reported against that data. If you try to report global data against the country data flow, and by global data I mean data coming from the SDG custodian agencies, it will be rejected. So that's a cube region constraint. Series constraints define valid or invalid combinations of codes. So this is where you can say that for SDG series, proportion of children moderately or severely stunted, the only valid age group is under 5 years old. And then you have the composite breakdown and product conductivity. So what that means is that if someone tries to send proportion of children moderately or severely stunted, age group 20 to 24 years old, it will be rejected. Or if someone says tries to send proportion of children moderate or severely stunted, age total, it will also be rejected. Total is not a valid code for this indicator. This indicator is only defined for children under 5 years of age. And the age group must be just that, under 5 years old. Is this clear? Any questions? All right, looks like we're good. Category scheme and categorization. When you go into this is particularly relevant to SDMX dissemination. Everybody is familiar with the hashtag. You use them in Twitter, you use them in all sorts of social networks. Hashtag Make America Great Again. Hashtag Donald Trump for President. Whatever. Or hashtag, you know, eliminate carbons by 2050, whatever. It's basically a label. A tag that you can attach to things like a tweet or an article on the web. And that lets you quickly identify articles or tweets which are related to a particular subject. Category in SDMX is just that, a tag. A way of classifying data for reporting or dissemination, primarily for dissemination. So you can create a category scheme, for example, economic statistics, demographic statistics, social statistics, and then you classify your data flows, typically, although it can be something else, by that purpose. Or you can create categories like SDG goal 1, SDG goal 2, SDG goal 3, and so on. You have the complete freedom. So that's what a category is, such a label. Demographic statistics, economic statistics, social statistics, and so on. Just like a code list is a maintainable list of codes, and a concept scheme is a maintainable list of concepts, category scheme is a maintainable list of categories. It's a maintainable unit. And categorization, you almost never create it by yourself. It's usually created automatically. It links a category to the object to which it applies. Content constraints and categories, in principle, they could be, especially like categories, could be applied to anything. And content constraints, they can be applied to data structure, data flow, provision agreement. But both categories and content constraints typically are applied to data flows. Because this is your main, as we discussed, transmission channel or dissemination channel. So this is the most natural place to apply categories and content constraints. All right. Whenever you send SDMX information from point A to point B, it is sent as something which is called SDMX message. SDMX message is nothing more than a container or a document for any SDMX related information. You have different types of SDMX messages. Structure message is used to send things like a concept scheme or data structure definition or code list. And then you have various data messages with various data formats. But the point is, whenever you say SDMX message, that means that it's a document containing SDMX information, which could be structure, could be data, could be even something else. Any questions? When do we have lunch? Yeah, we'll go. Now, SDMX artifacts. Now, if you read the specification of the SDMX standard, which I assure you is no easy reading, if you read that, you will see that there are various types of SDMX artifacts. However, when you talk about SDMX artifact, then most often, usually, SDMX artifact means a maintainable and versionable component of structural metadata. A concept scheme, a DSD, a code list, they are all structural artifacts. They're all SDMX artifacts. Now, SDMX code is usually not referred to as an artifact. Strictly speaking, it is, but it's not maintainable. But usually, when people talk about SDMX artifacts, they mean maintainable artifacts. And they don't usually refer to an SDMX code or an SDMX concept or an SDMX category, individual category, as an artifact. They usually talk about code lists, concept schemes, data structures, and so on. Okay. Any questions? Now, this is very, very important. Identification and versioning. We've talked a lot about identifying data, right? We've talked about dimensions, we've talked about keys, we've talked about series keys, for example, right? But SDMX artifacts, they also need to be identified. And SDMX artifacts have three pieces of identity: ID, maintenance agency, and version. If you are looking at two messages, and each one of them has an SDMX artifact with the same ID, agency, and version, that means that it's the same artifact. Okay? This is very important to understand. Whenever you update an SDMX artifact, you must update at least one of these. Because whenever you're making any update to an artifact, that makes a new artifact. And if you don't change the identity, you're asking for trouble. So, this is particularly relevant to the customization of the SDG data structure definition. If you want to extend the global SDG DSD with Thailand's province codes, for example, if you want to do that, you need to make changes to the code list and the data structure definition and the data. We'll go over that in more detail. But the point is that if you want to make changes to the global reference area code list, you must take ownership of that. You must say that the maintenance agency is not the IGSDGs, but the TNSO. And then you also said you can keep the same ID as long as you change the agency, it will make sense. And then you can assign the same or a different version. The point is, you change the maintenance agency to your own, you're creating a new artifact which you own and you maintain. And that is what you must always do whenever you update any artifact. Any question? No questions? Thank you. We have completed a quick, very, very quick overview of the SDMX information model. it was so quick because this is an advanced course and this is one day of pressure. So after lunch, we'll do an exercise together and make sure that we understand what we covered. So we now have lunch, and how will we come back when? So we even finished a little earlier. Let's have lunch now and come back at 1:30 in 1 hour and 12 minutes. Please don't be late. Thank you very much.